In level 3, you will be applying reflections, stretches, and compressions or shrinks to parent functions. You may also have shifts horizontally and vertically as well. So we're going to start with reflections. A negative inside or outside of the function causes a reflection. If the negative is outside the function, that anything that happens outside affects it vertically. It affects the y values. So the function would shift or reflect vertically, and it will reflect over the x-axis. Now, even though we have the word x-axis, this is affecting the y values. Imagine if you had a parabola facing up and you reflected it over the x-axis, it would end up upside down. So it's a vertical reflection, top to bottom. It reflects over the x-axis. Now, if you have a negative inside, it's going to affect the graph horizontally. It affects the x values. It's a side-to-side reflection, which would be a reflection over the y-axis. So imagine you have a radical function and you reflect it over the y-axis, it would go backwards like that. So it's a side-to-side reflection when the negative is on the inside. Now, if you have a number in front of the function, again, anything outside affects it vertically, it affects the y values. If that number is greater than 1, it is a vertical stretch by a factor of c. So if you had a 2 in front, the function would get twice as tall. If that number in front is between 0 and 1, so something like 1/2 or 1/3, it would be a vertical compression, which is the same as a shrink by a factor of c. So if you had a 1/2 in the front, the function would get half as tall. For the next one, a c inside, a number inside by x, just like with our horizontal shifts, they were counterintuitive. When we had a minus, instead of going in the negative direction, it went in the positive direction. When we had a plus, we shifted in the negative direction. It's the opposite of what we would expect to happen. The same thing happens with our horizontal stretches and compressions. If you have a number that's greater than 1 inside, we would think that it would stretch it horizontally and get wider, but it doesn't. It does the opposite. It gets compressed. So if you have a number greater than 1, it's a horizontal compression or shrink by a factor of 1/c. So for example, if you had f of x or f of 2x, the function would get half as wide. Okay. And if you have a number that's a fraction less than 1, between 0 and 1, we would think that that would make it skinnier, but it doesn't. It makes it wider. That's a horizontal stretch. So again, it's the opposite of what you would expect. So a horizontal stretch by a factor of 1/c. So for example, if you had f of x equals 1/2 x, it would get twice as wide. for some examples, we're going to look at various transformations of the radical function. The radical function looks like this. We start at the origin, we go over 1 up 1, square root of 1 is 1, and then our next nice point that we would plot is the square root of 4 is 2, so over 4 up 2, and then the square root of 9 is 3, over 9 up 3. And there's the radical function. For this first transformation, the negative on the inside is a horizontal reflection, side to side, which reflects over the y-axis. And then this plus 2 is a shift. It goes up 2. So my graph is going to go this way, and it's also going to move up 2. But of course I want to plot accurate points. So if I start with my point 0, 0, it's not going to reflect anywhere because it's on the y-axis, but it is going to move up 2. Now the next point was over 1 up 1, but it is going to reflect and be on this side. And I'm going to go now to the left 4, up 2, to the left 9, and up 3. So the function reflected over the y-axis horizontally, side to side, and then it shifted up 2. In this next example, we have another reflection, but now the negative is outside, and anything that happens outside affects the y values or affects it vertically. So this is a vertical reflection, and it reflects over the x-axis. So top to bottom reflection. It also has a 2 out front. Again, it's affecting it vertically when it's in the outside. And so this is going to be a vertical stretch by a factor of 2. And then this plus 3 is on the inside, so that's going to affect it horizontally, and it's going to be a shift 3 units to the, remember it's counterintuitive, I would think right, but it's to the left. Okay, so my point that started at the origin in the parent function needs to shift 3 units to the left. And it's going to stay on the x-axis. It's not, that point will not reflect since it's on the x-axis. My next point, which was over 1 up 1, the vertical stretch would make it go over 1 up 2, but the reflection is going to make it go down below 2. So it's down here. My next point would have been over 4 up 2, but I need it to be twice as tall, so it's going to go over 4 up 4. I'm taking that y value and multiplying it by 2. My next point would have been over 9 up 3, but I double that y value, and it's going to be over 9 up 6, but again, because of the reflection, it's going to go down 6. So I go over 9 and down 6. So it got twice as tall. It's upside down. It reflected over the x-axis. It reflected vertically, and it shifted 3 units to the left. And this last example is an example of a horizontal compression. Remember, if we have a number that's greater than 1, we would think it would make it get wider, but it's always counterintuitive on the inside. It makes it get skinnier. So this is a horizontal compression by a factor of, and we take the reciprocal of that number, so it's 1 over 2. It gets half as wide. So now this is affecting the x values. My first point is going to stay at the origin. It's not going to change. But my next point, which was over 1, is only going to be over a half, and then up 1. So it isn't how high it goes isn't affected, it's how wide it is, or how far to the right. My next point would have been over 4 and up 2, but I only go half as far horizontally, so my x value is going to be over 2 up 2. The y isn't affected again. And then my next one should be in the parent function over 9. I go half as far, so I go over 4.5, and then still up 3. And that function was shrunk in half horizontally, or compressed horizontally, by a factor of 1/2. In this next example, we have to write the equation of this graph. So if we think about the parent function, this looks like an x squared transformation. The parent function for x squared looks like this. Okay, so if I think about what happened to this graph to give me the graph that I have. Well, it definitely shifted left and up. And so shift left, it shifted up. It also reflected because it's upside down. And it looks like it got stretched out vertically because in the original graph I went over 1 up 1, but this graph has the points over 1 down 3. So first let's think about our shift. So from the origin it looks like it shifted 3 units to the left. So left 3. And then it went up 8. Then it reflected vertically, so it reflected over the x-axis. And it stretched vertically by a factor of 3, because this point went, which should have gone over 1 down 1, went over 1 down 3. So it's 3 times taller than it would have been in the parent function. So to write this as a function, I say f of x equals, now everything that happens vertically goes on the outside. So my up 8 is going to go on the outside, and the 3 goes on the outside, and my vertical reflection. So all of these are going to go on the outside. So we get a negative because of our vertical reflection over the x-axis. The vertical stretch by a factor of 3 puts a 3 in the front. And then we put our parentheses. And also, this is going to be squared, also on the outside, our up 8 would be a plus 8 at the end. Now on the inside, we shift left, so I would think it would be x minus 3, but remember, it's always the opposite of what we'd think, so it's going to be x plus 3 to shift left 3. And that would be the function. In this last example, we are applying 2 different transformations to this graph. So if we think about the points that we're starting with, it looks like we have the point negative 5, 5, 0, 0, 2, 3, and 5, 3. Our first transformation for part A is negative 2g of x. Since this negative 2 is on the outside, these are both vertical transformations. The negative is going to reflect it vertically, or reflect over the x-axis. And the 2 is going to be a vertical stretch. So it's going to get twice as tall, so by a factor of 2. So my point at the origin, 0, 0, isn't going to change. This point, negative 5, 5, is stretching vertically by a factor of 2, so it would be negative 5, 10, but it's also flipping upside down, so we're going to get negative 5, negative 10. Now my next point at 2, 3, it's reflecting, so it goes upside down and it gets twice as tall. So instead of being over 2 up 3, it's going to go over 2 down 6. And my next point, which is 5, 3, is still going to be over 5, but it's going to be down twice as far. Instead of 3, again, it's going to be 6. And that's reflected over the x-axis and stretched vertically by a factor of 2. Now this other reflection, g of 1/2 x plus 3, the 1/2 is going to be it's on the inside, so a horizontal. And remember, a number between 0 and 1, it's not a compression, it's a stretch. It's going to get wider. So stretch by a factor of, and we take the reciprocal, by a factor of 2. So this is going to get twice as wide. And then the plus 3 shifts it up 3. To graph this function, I'm going to start with the point at the origin. The horizontal stretch is not going to affect that point since its x value is 0, but it is going to be shifted up 3. So my first point is going to be at 0, 3. Now this point on the left side that started at negative 5, 5 is going to be stretched horizontally by a factor of 2, so it's going to be twice as wide. Instead of going left 5, I'm going to go left 10. But I also have to shift it up 3 because the whole graph is moving up 3. So instead of being at at the vertical height of 5, it's going to move up to 8. So we get negative 10, 8. Now the first point on the right at 2, 3 is going to go twice as wide, so it's going to go over to 4 on the x-axis, and then it's also going to move up 3, so it will be at 4, 6. And my last point is going to go twice as wide. Instead of being over 5, it's going to go to the right 10, and then also up 3, so it moves up to a y value of 6. So that transformation is twice as wide, stretched by a factor of 2, and shifted up 3.